This is week 13 notes factoring by grouping. In this lesson, we're going to be factoring by grouping. Imagine that. It involves taking the GCF like we were doing the last two lessons. But if you guys could please write down the steps. Okay, so the first example is going to be 2b times the quantity b plus 3 plus 5 b times b plus 3. Now, we are going to GCF factor, or excuse me, not GCF, but factor by grouping. I'm so used to GCF, but in a sense, we are going to GCF factor out this binomial. And this problem is actually going to start with step 3, GCF factor out the binomial in parentheses. That is this right here. So you can see what are two things being multiplied together here and here, here and here like that. That means that they're factors. So that means that this term right here and this term right here both have a common factor. And that is what I just underlined here, the b plus 3. So what we're going to do is pull out that b plus 3. So I'm gonna copy this again down here and then show you a little trick to help you visualize what it is we're doing. So I'm going to essentially pull out, as a factor, pull out the b plus, actually I'm gonna move this over a little bit more. As a factor, I'm going to pull out the b plus 3, put it off to the side here, pull it out from the first term, and then, well, actually, let's just, so I can show you so many different ways I can demonstrate this, but I'll show you. This is the first term, and this is the second term right here. All right. Again, let's try this. I'm going to pull this term out right here, put it out in front. Then I'm going to do the same thing and pull out the b plus 3 from the second term, and it's going to go right out in front too, so that you can see what is clearly happening here. Now, all we have to do is leave this as one binomial right here, and our answer then is just going to be a b plus 3 times a 2b plus 5. And you can see that, yes, our answer should be a binomial times a binomial, and indeed it is. In some other examples, we're going to have to separate the initial problem into two sets of parentheses and factor out both sides, like we're going to do in the next example. But showing you what just happened right there, we just factored out the b plus 3. Number 2. We've got negative 4x times x plus 2 plus 9 times x plus 2. And between these two terms here, I think you can immediately see that x plus 2 is a common factor. That means that we can pull out x plus 2 from each of these terms, being a common factor. And that means that what we are left with is a negative 4x, which was right here, and then the plus 9, which is right there. And that is our factored form. Now again, we only started with step 3 here. We'll do problems that involve a couple more steps, but just so you can get an idea of what we're doing. Let's do number 3. Number 3. X cubed plus 3x squared plus 5x plus 15. Okay, now this is starting to look a little different, right? How do we solve this? Let's follow the steps up here. So first thing we're going to do is separate into two sets of parentheses. That's step one. So let's separate that into two sets of parentheses right here, okay? And for these first few problems, it's really just going to be the first two in parentheses and then the second two in parentheses, right in order like that. Then we're going to GCF factor both sets, okay? So we're going to GCF factor this right here, and then we're going to GCF factor this right here. Let's do that. What's the biggest thing I can pull out from both of these terms? And if you said an x squared, you would be correct. So that's leaving an x there. We pulled out an x squared. That means we're left with an x, and then we're left with a 3 right there. Okay, so we GCF factored this one. Now let's GCF factor this one. Biggest thing I can pull out from both of these terms is a 5. So I'm going to pull out a 5. And that means the 5 goes away here, and we're just left with an x. And then the 15 gets divided by 5 and becomes a 3. So now this is looking a lot like the first couple problems we had. So what is the common factor between these two terms right here? And if you said x plus 3, you're correct. So let's factor out again an x plus 3. And then what we're left with is the x squared plus the 5 right there. X squared plus the 5. And you can see what happened there. We literally just pulled out x plus 3 from this term, right here, this whole term, and the x plus 3 from this whole term right here. And we got this, binomial times a binomial. All right. Next question here. I think we'll probably go down to the next page. Number 4. 2r squared minus 6r plus 12 minus 4r. First thing we have to do is group into two sets of parentheses. Then we need to GCF factor out, or GCF factor both sets. What's the greatest common factor of this first set right here? That would be 2r. Biggest thing I can pull out. So if I pull out a 2r from right here, it just leaves me with an r. If I pull out a 2r from here, it leaves me with a negative 3. All right, now let's do the same thing over here. GCF factor this. We can pull out from, biggest thing we can pull out from both is a 4. So I'm going to pull out a 4, and then I'm left with a 3. And then I have a minus r right here. Okay, now here's a little trick. Since we have r minus 3 and then a 3 minus r right here. What we can do to switch this, in a sense, you can, this is a little trick, maybe this is kind of advanced, but think about it for a second. 3 minus r is the same thing as negative r minus 3. If you think about this, it really makes sense, because if you distribute the negative to the r and then to the negative 3, you really get a negative r plus 3, and that's the same thing as a 3 minus r. So what you can do to just make this turn into r minus 3, like we have over here, is just make it negative. And then so what that would mean is you put a negative in front of the 4. So we'll go 2r times r minus 3, and then negative 4 r minus 3. So we switched the sign there, and then it allowed us to really just get the same thing, okay? So now what we get to do is factor out that binomial right here. So we'll factor this out, r minus 3, and then we're left with a 2r minus 4. All right. let's try a few more. Number 5. 3r minus r squared plus 2r minus 6. Take a moment to try this on your own. Assuming you've tried, first thing we do is group according to the way we did before. And then we have to pull out the GCF from both sets. The GCF of this first set would be just an r. We can pull out an r, no problem. But we're left with a 3 when we pull out an r from that. And then when we pull out an r from this, we're just left with a negative r. 3 minus r. Okay. And then over here, the biggest thing we can pull out is a 2. So we will pull out a 2. And then we're left with with an r there, and then a minus 3 here. And again, we have the same type of thing happening, where we have 3 minus r and then r minus 3. Well, we can switch either this one or switch that one, and then just make it negative. Just flip it around and make it negative. So I'm just gonna flip this one around and make it negative. Let's do that here. So I'll rewrite this. Actually, you know what? I'm gonna flip this one around. I changed my mind. So it's gonna be a negative r, and then r minus 3. And you'll notice that this is actually equivalent to this. It's equivalent when you multiply it out. It's really effectively the same exact thing. All right, so but now we have an r minus 3 here and an r minus 3 here. So we will pull that out as a red common factor. And that's the goal here, is trying to do that. All right, so r minus 3 will be pulled out. So that can go off of that term and then off of that term. We divided it out. And then we're left with a negative r right here. And then the plus 2 right there, plus 2. And that's what we're left with, a binomial. And what I like to kind of do is write this like 2 minus r, but you can leave it like that in this form. Totally fine. Let's do one more down here, number 6. 10b to the third minus 16b squared plus 25b minus 40. All right, I would encourage you to pause and try this on your own. Assuming you've tried it, first thing we're going to do is group with parentheses, both sets of terms. Then we're going to factor out the greatest common factor from each set. The greatest common factor of this set right here, let's think for a second. Biggest thing I can pull out is from 10 and 16. Well, biggest thing I can divide both those by is 2. So that's fine. Let's pull out a 2 from here, and then I can also pull out a b squared. That's the lower one. Okay, so I can pull out a 2b squared from this and from that. And what they become when I pull it out is, this one is 5b, because we had 3 b's and now we pulled out 2. And then this one becomes simply an 8, right? Because we pulled out a 2b squared. This, what can we pull out? Let's see. Greatest common factor. Well, you got to keep in mind that we're trying to get this as what's left over. So keep that in mind. So what would 5b have to be multiplied to get to 25b? And what would 8 or negative 8 have to be multiplied to get to negative 40? And if you said 5, then you're correct. So let's pull out a 5. And that's really what would allow us to factor these. And it just so happens that 5 really truly is the greatest common factor between these two terms. So we will pull out that binomial from both of these terms. Essentially, we're just GCF factoring again. It's really the GCF is right here. We're just factoring out. It's just a binomial. It's not one term, it's two terms. And then we'll write the 2b squared and the plus 5 right down here next to it. And we are done.